let's evaluate the integral tan cubed x times secant to the fourth x. Whenever we have power of tangent times the power of secant, there are two techniques that we should use. First, we look for even power of secant. In this case, we have 4, so it is even. Or odd power of tangent. And in this case, that happens to be 3, so that's also true. This will allow us two different ways of solving this problem. I'll go ahead and illustrate both techniques. You should look and see how they're done, and when you encounter a problem, if you have, let's say, an odd power of secant and an odd power of tangent, you use the second technique. And then if you have an even power of tangent and an even power of secant, you'll use the first technique. So here's how the first technique works. Using the fact that the power of secant is even, we split off secant squared from the original power of secant. If I split off secant squared from secant to the fourth, that leaves another secant squared behind. Then we're going to use the trig identity, which is tan squared x plus 1 equals to secant squared x. We're going to replace one of these secant squares with tangent squared plus 1. So we get tan cubed x times tangent squared x plus 1 times secant squared x dx, which is equal to tangent to the fifth x plus tangent cubed x times secant squared x dx. And we'll be using just regular u substitution. I hope that's obvious here. U will be tangent, du will become secant squared x dx, and the integral becomes integral of u to the fifth plus u to the third du, which is 1/6 u to the 6th plus 1/4 u to the 4th, plus, let's call constant of integration c1. And so this is 1/6 times tangent to the 6th power x plus 1/4 tangent to the 4th of x plus c1. That's the first method of solving this. The second method, using the fact that the power of tangent is odd, we're going to split off one power of tangent and one power of secant. So originally we had tangent cubed, so that leaves tangent squared, and we had secant to the fourth, that leaves secant cubed. And once again, we'll be using the same identity, but this time we'll solve for tangent squared. Tangent squared equals to secant squared x minus 1. So this tangent square will be replaced with secant squared minus 1. And that leaves, let me switch these, secant x, tangent x. Then tangent squared becomes secant squared x minus 1 times secant cubed x dx. Again, simplifying it before we substitute. So this is secant x times tangent x times secant to the fifth x minus secant cubed x dx. We're going to let u equal to secant x this time. Du becomes secant x tangent x dx, and our integral looks like this: u to the fifth minus u to the third du, which is 1/6 u to the sixth minus 1/4 u to the fourth, the constant of integration, call it c2. So this is 1/6 times secant to the 6x minus 1/4 times secant to the 4th x plus c2. And that's the second way of doing this problem. Now, if you recall what the answer was for the first part, the answer for the first part was, or the first method was 1/6 tan to the 6th x plus 1/4 tangent to the 4th x plus c1. the answer we just got for the second method is 1/6 secant to the 6 minus 1/4 secant to the 4th plus C2. So it looks like the two answers are different, which of course cannot be. Every integral has a unique solution up to a constant of integration. So something is either wrong or these two answers are the same. In fact, these two answers are precisely the same. So I'm going to show you that we can make the first look like the second or the second look like the first. So let's make the second look like the first. I'm going to rewrite it as 1/6 times secant squared x cubed. It's the same as secant to the 6 minus 1/4 times secant squared x squared plus this constant of integration C2, and I'm going to make it look like the first answer, that they are really one and the same. Using the identity secant squared x equal to tangent squared x plus 1, we'll replace secant squared by tangent squared plus 1. So we get 1/6 times tangent squared x plus 1 cubed minus 1/4 tangent squared x plus 1 squared plus C2. Now we have to expand this. I'm going to leave it up to you to go ahead and multiply this. It's not that hard if you remember the formula for cubing something. Here's what we get. 1/6 tangent squared x plus 1 becomes, that's cubed, tangent to the 6x plus 3 tangent to the 4th x plus 3 tangent squared x plus 1 minus 1/4, of course tangent squared x plus 1 is tangent to the 4th x plus 2 times tangent squared x plus 1, and then we have this constant of integration C2. So here's what we have. 1/6 tan to the 6. 3/6 is plus 1/2 tangent to the 4th plus 1/2 tan squared plus 1/6 minus 1/4 tangent to the 4th minus 1/2 tangent squared minus 1/4 plus C2. Okay, so simplifying this, first of all, 1/2 tangent squared x minus 1/2 tangent squared cancel. We have 1/6 tangent to the 6, 1/2 tangent to the 4th, that's 2/4, minus 1/4 tangent to the 4th, that's 1/4, yields positive 1/4 tangent to the 4th x. 1/6, that's 2/12 minus 1/4 is 3/12 minus 1/12 plus C2. We can now take minus 1/12 plus C2 and call it C1. So we end up with the answer for the first method, which is 1/6 tangent to the 6x plus 1/4 tan to the 4th x plus C1. So the two solutions are the same. Oftentimes when you do problems like this, depending on what method you use, the solutions could look quite different, but just know if you did everything right, they can be made to be the same by applying a trig identity. For more videos, visit www.mathprepvideos.com.